Hey guys, here we are in chapter 6. We are looking at 6.6, which is the end of the chapter, and we're going to be graphing inequalities in two variables. So let's get our graphing hats on and let's talk a little bit about what this will look like. So we're going to talk about basically when we're graphing these types of inequalities. We're thinking about graphing them no longer on just the x-axis. We're going to graph them on the xy plane. And so you remember what we also graphed on the xy plane. So far we've graphed linear equations. So we're going to take linear equations and we're going to bring them in with this idea of graphing inequality. So we might have something like this: y is greater than, let's say, 2x minus 5, right? And so I know how to graph this. I'm going to start with the y-intercept, and that's at -5. So I should be going down and not up. So that's here. And then my slope is 2, so that tells me go up 2 over 1, up 2 over 1, up 2 over 1. So I should get a graph like this. Now, I'm getting to these words. What happens is this is the line. Now notice I'm drawing the line dotted because y doesn't actually equal to this thing here. Y is greater than that. And then what I'm going to show you as we go about our business and we do our lesson is that y is greater than, so I'm going to shade up and I'll show you why. So the answer to this, or the graph of this inequality, would look like this. Why am I showing you this? Because I want you to know that the graph will always be a half plane. If we think about the xy axis as a plane, notice that we're always going to be graphing half of it, right? You know, it might not look like half because of where we start, right? I could have, tried to center it a little bit better, but the reality is I'm going to be shading half of the xy plane when I graph these types of inequalities. One. The second thing is the boundary. The boundary that we have will either be a dotted line like this one is, or sometimes we'll have a solid line. That solid line comes about is if I throw let's use a solid pen. If I throw a equal to, greater than or equal to, then I'd have to include the line. Then I'd have to include that line. Well, it's not there, so I'm not going to do that. But that's what the boundary would be. So either you're going to have a dotted or a solid boundary. All right, so that's the boundary in the half plane, and let's move on to some examples. Here in example 1, we're going to be checking out whether ordered pairs satisfies an inequality. So we're given the following inequality. We've got 3x plus 2y is less than 12, and we want to figure out which ones satisfy this inequality. So literally we're going to plug in for x and y and see if these different xy pairs make this inequality happy. All right, so 3 times 1 plus, I'm trying this first one out, 2 times 6. Is that less than 12? Let's see, 3 plus 12 is not less than 12. So this guy doesn't satisfy that inequality. And for the sake of space, I'm going to just come back in here and just delete the things that don't work and go ahead and plug in some other ones. So 3, 0. When I plug in 3 for x and 0 for y, will this work? 3 times 3 is 9 plus 2 times 0 is 0. Is that less than 12? Aha, it works. So this is a solution, right? Again, just going to delete that, and let's go ahead and try this next one. Let's plug a 2 in, and when I do that, I get 6 plus 4, which is indeed less than 12. This is also a pair that works. And then finally, I'm going to do 4, 3 by getting rid of that, plugging in 4, plugging in 3, I get 12 plus 6, which is not less than 12. 12 plus 6 is 18, so this guy doesn't work. So what I have here is that the ordered pairs 3, 0 and 2, 2 are solutions that work. They're part of the solution set that works. And so when I graph this, which is not what we're talking about right now, but when I graph this, I'm going to graph the side. I want to shade the side where these points are. And we'll talk about how to get there. All right, so we have a little bit of a key concept. We've got the idea of a half plane being shaded in. You're going to choose one side as the solution and the boundary is the line. So we're going to practice graphing those. So let's start off with this one. This is really nice. I like that this equation is almost in slope-intercept form, right? Y minus 2x is less than negative 4. Looks almost like y equals mx plus b, where I'd have to bring this over to the other side. And so I'm going to do that. This is fun, right? We love putting it in that form. So here's what I'll do. First, I'm going to graph the related line. I'm going to call it the related line. Because, this isn't a line, this isn't an equal sign. So the related line will be y minus 2x is equal to negative 4. And then I'm going to put that related line in slope-intercept form because that's easy for me to graph. Move that 2x over to the other side. So it's a positive 2x minus 4. And now I can graph this line. So I'm going to get started with that. Nope, I can draw a straight line. I promise I can. That's a little bit better. All right. So we have this. And this is kind of like the line that I had before. I'm going to start off with the y-intercept being negative 4. That's y-axis and the x-axis. And my slope is 2 over 1. So I go up 2 over 1, up 2 over 1, and I can continue doing that. Now the question, now that I've graphed or started graphing the related line, I have to ask myself, will this be a solid line or a dotted line? Because this inequality, I'll write it down, y is less than or equal to 2x minus 4, just moving that 2x over to the other side. Y is less than or equal to 2x minus 4. This tells me I'm going to have a solid line. So this line should be solid and not dotted because y can be less than or equal to. Now, when I was doing this back in the day, 100,000 years ago, I would honestly not really pay attention to anything else. I just look at this thing and go, oh, y is less than, where is y less than, above or below? It's below, and I'd shade down. And that totally is legit, but that's not the most thoughtful way to do this problem. So your text and other texts will tell you, now that you have drawn a line and split the plane into two separate places, the question is where to shade. So what you're supposed to do is grab some point, let's say the origin, and you will plug that point, some random point, you plug it into the inequality. If that point satisfies the inequality, just like we practiced in this last example, we saw what points satisfied the inequality. If the random point you choose satisfies the inequality, then that is the side you shade. If that random point you choose does not satisfy the inequality, then you shade the other side. Okay? So let's go ahead and do the thing. So now what I'll do is I'll plug in 0, 0, because this is my, oh, that's way huge. I'll plug in 0, 0, which is the point that I'm concerned about, that guy right there. And so I plug in 0 less than or equal to 2 times 0 minus 4. And is 0 less than or equal to 2 times 0 is 0 less than or equal to negative 4? Is 0 smaller than negative 4? The answer is no. So since that does not work, then I don't want this side as my solution. I want the opposite side. All right. So I am looking for this side here. Everything below this line is the half of the plane that will support my answer. And so I can choose any point here and it's going to work. Now, like I said before, that is not how I did it. I don't know why. I don't know if our teacher taught us that, but my teacher was just like, or I was just like, okay, since y, I isolate y, since y is less than or equal to this thing, y has to be below. And you notice it agrees. But I do like the idea of checking a point, so that's totally cool too. Let's look at another example because I am talking a lot. Write and solve an inequality. So we've got Rosa Padilla sells radio advertisements in 30-second and 60-second time slots. During every hour, there are up to 15 minutes available for commercials. How many commercial slots can she sell for 1 hour of broadcasting? So the first thing I want to do is kind of identify some variables. Let X be the number of 30-second slots and let Y be the number of 60-second slots. So if X is the number of 30-second slots, then for each X, there's going to be 30 seconds. So 30X is the amount of time that the 30-second slots take, right, altogether. And similarly, 60Y is the number of seconds that the 60-second slots take up, right? So if like Y is 2 and I had two 60-second slots, then that would be 2 minutes, right? Or 120 seconds, whatever. During every hour, we can have up to 15 minutes of commercial broadcasting, and so we want to know how many commercial slots can she sell for 1 hour broadcasting, which is just 15 minutes, right? So since I'm dealing with seconds here, I'm going to change this to minutes. I'm going to change my minutes to seconds rather. So I know 15 minutes in each of the 15 minutes there's 60 seconds. So I know that that's going to be, I don't know, 15 times 60, which is going to be, what is that, 900? So 900. Now, the fact of the matter is that's 900 seconds. So the fact of the matter is that this doesn't have to equal. She can sell less than. We want to know how many she can sell. So we know that this has to be less than or equal to. She can sell less, or she can sell all of the slots, right? So this is the inequality that we're going to work on. And so we want to know how many commercial slots can she sell for 1 hour of broadcasting. The fact of the matter is that there's not one answer. It depends on the number of 30 seconds slots and the number of 60-second slots. So since there isn't one answer, I'm going to graphically represent my answers. So I'm going to solve for Y, which always makes sense and helps me graph. So I'm going to start off by doing that, get rid of the 30X. So I have 60Y is less than or equal to negative 30X plus 900. And I'm going to divide everything by 60. So I'm isolating my Y. Y is less than or equal to negative 30 over 60 is negative 1/2. X, and 900 divided by 60 is 15. So I get this beautiful equation right now. All right. And so this is the relationship that I have. And so now I'm going to graph that. So let me go ahead and get started. I'm going to put a dot here, which is my y-intercept. And I notice I numbered this by ones and I numbered this side by twos. Well, no, I numbered this side by ones and this side by twos. My bad. And so if my rise is 1, my run is 2. I'm just going to go over here. Rise 1 over 2. And my graph is going to look like this. It's a solid line. So I'm going to do something, should do something like that. All right. So this is my graph. If I were to graph it like that. And then, so now, where am I going to shade? Now, according to my little thing, I would shade downward, but I could also pick a point and plug it into the inequality and see if it works. I like picking 0, 0 because it's easy, but I can pick some other point. So the question is really, does it make sense for me to, say, have 10 of the 30-second, because remember, X is the 30-second slots, and 5 of the other type of slots, the 60-second slots. And if I plug it into the equation, you're going to see the inequality, you're going to see it's going to work, because if I put 10 here, I get 300 plus 5 times 60 is another 300. Is that less than or equal to the 900 seconds that we have for commercials? Yes. So that tells me in no uncertain terms that I can shade this side of my inequality. And because this is real life, I'm really not going to deal with half the plane. I would probably stop at the lines because I can't really have negative values for the slots, for the time slots. So my answers are going to be found all up in this section here. All right. All right, I hope that made sense. And I know that sometimes these inequalities can be a little bit tricky. let me know. Let's talk about it. Let's do our thing. This is the end of the chapter. Let's make sure we're confident about all the stuff. So be sure to have some questions for me the next time we get together or even before. All right. Take care, guys. Bye bye.